So a lot of times students have problems with questions where the values have to be converted into other units, right? So unit conversion issues. And they have problems with questions that have hidden geometry in them. So what does the SAT do, right? They make questions that have both those issues to really challenge you. And those are some of the hard questions on the test. So we're going to go through in this video 2 questions that are very similar to each other. I'll do both of them, but the first one you can sort of watch along if you're confused, and then try the second one on your own and see how you feel about it. So here the question is the density of a certain type of metal is 238 kilograms per cubic foot. A cube made of this metal is found to have a mass of 230 kilograms. To the nearest hundredth of a foot, what is the length of one edge of this sample? So we're told that it's a cube, right? That should hint that we're already talking about shapes and geometry, right? Three-dimensional geometry, right? Because a cube is a three-dimensional object. And then the density, right, is also involved in geometry and with units, right? So the units here are kilograms per cubic foot. And a cube, right, is the same side length cubed. That's how we'd find its volume, right? So we could call all these like n. So to the nearest hundredth of a foot, what is the length of one edge of this sample? Okay, so we're going to take the 233 kilograms, right? And that's the mass that we're dealing with, and we're going to convert that into volume and then convert the volume into edge length, right? Now remember, density equals mass divided by volume, right? So here we have 238 kilograms over 1 cubic foot. So we're going to do railroad method with the 233 kilograms to find how many feet cubed we have, cubic feet we have. So it's going to be 233 kilograms. And then we're going to do 1 foot cubed, right? Because that's how much is in 238 kilograms. And we know to put the kilograms on the bottom because we want the units to cancel out and we want to be left with the cubic feet units. Okay, so now what we do is we do 233 divided by 238. And that's going to give us 233 divided by 238 gives us 0.979. And I'm a big fan of not using calculators, but even I use a calculator for this. So this is feet cubed. Now that's volume, right? And it's not asking for volume, and I think a lot of people would get thrown off and see 2.979 and they would round up to this one and find it from there, but we're not going to do that, right? Because this is the volume and it's asking for the length of one side. So we're going to do n cubed equals 0.979, and then you're going to find that n equals, right, 0.979 to the 1/3 power, or you can think about it as the cubic root of 0.979, and that gives us 9929, which when you round becomes 0.99. So that would be B, right? So it's complicated because we're dealing with density, which has 2 units, right? Kilograms and cubic feet. And then we have to use the mass that we're given to find the volume of this object, which is more simple once we get there. But the big trick is to remember to convert the volume into length, right? And I think that's one step where people will get thrown off. A lot of people, I think there's sort of funnels of places where people get messed up. And the first funnel is like reading the question, understanding it. A lot of people get stopped there. And then the other one is forgetting to convert the volume into length, right? They sort of bombard you with information and then are trying to overwhelm you with it. But if you stay focused and you are feeling comfortable with it, it shouldn't be too bad. So let's try another one now that you've done this one. The next one will be very similar, and you can test out your skills there. Okay, so as you can see on this one, right, it's very similar to the last one. I've just switched it up a little bit, but if you are comfortable with the first one, this one shouldn't be too bad either. The density of a certain type of wood is 320 kilograms per cubic meter. A block of this wood with a base with an area of 4 square meters is found to have a mass of 640 kilograms. What is the height of the block in meters? Okay, so now we're not dealing with a cube, we're dealing with a rectangular prism, right? And rectangular prism's volume equals length times width times height. Okay, and we're told that the area of the base, so let's say LW, is 4. So LW equals 4, so the volume is going to be 4H. And if you were to make a chart, right, it would look something like okay, I'm not a great artist, but let's say this is 4 and then we're trying to find the height. So how do we do it again, right? Density equals mass over volume, okay? With a base with an area is found to have a mass of 640 kilograms. So mass, right, is equal to dV. So V is equal to M over D, right? You don't really need to think that through, but I'm just sort of writing it out here. So we're going to do what we did last time. We're starting with 640 kilograms. This time the math is a little easier. It's not decimals exactly, but so 640 kg, 320 kilograms per cubic meter. So 1 cubic meter over 320 kilograms. And that's going to get us 2 meters cubed, right? So that's our volume, equals V. And that means that equals 4H. So to find H, we do 2 divided by 4 equals H. So H equals 0.5 or 1/2, right? So it'll be B. So it's the same process. The shape has changed a bit, but all you need to do is know the formula for the volume of that shape and then do the same process of converting units, going from density and using that formula to go from mass to volume, okay? If you feel confident after these two, that's great. These are some of the 2 hardest questions that you could see in the ratios and proportional and rates section of the SAT. And, you know, if you can get these, I think you can get almost any type of question on this test. So let me know if you have questions on this or doubts. I'll be happy to cover them for you again in the future. And I'll be doing more videos like this, like always. Otherwise, I hope you're all doing well and that it's sunny where you are. And if it's snowing, I hope it is leaving a quiet blanket on the streets for you. Talk to you soon. Bye.